Bruh. My mic was muted the whole time. Bruh. My mic was muted the whole time. Bruh. That is actually tough. That's worse than when you're in the party and you play a whole half of the game with your mic on mute. Well, I said a lot too. That's tough. I was just talking to myself. Really, all you missed was I have a Discord. I put the link in the chat. Just post your problems and I'll answer them. That's basically all I was saying. All right, number 5. Which of the following is equivalent to the expression above? As I look at said expression, they're trying to trick you with the minus a whole quantity. You're subtracting. Basically, you're distributing this minus sign. That's one way you could think of it. Or you can think of it like you're subtracting each individual term. So it's not just minus and then just copy everything. You have to subtract individually. So I'm just going to write it out the long way. So this is going to be what? X squared y minus 3y squared plus 5xy squared. Now, here's where I'm actually going to do something. If I distribute that inside minus sign, that negative times a negative is going to give me a positive. So I'm going to say plus x squared y minus 3xy squared plus 3y squared. Combine like terms, let me see. So I'm going to highlight them for y'all. So I got boom, boom, and that's it, because those are the only x squared y's. And then I have an xy squared term, or two of them, xy squared. And then I got y squared as well, which actually are going to cancel out. I got a negative 3y squared and a positive 3y squared. So those are going to cancel. So let me just combine my greens. I got one x squared y plus another x squared y. That should be 2x squared y. And then if I combine my purples, 5 minus 3 is a positive 2xy squared, which is exactly what C says. 2x squared. Yeah, we're good. Okay, number 6. Number 6. All right. I lost a viewer, man. Dang it. I had 2 people in here. Yeah. Oh, man. Bro, if you're live on YouTube, I can't hear the audio. I know, bro. I just fixed it. You hear it now? Question mark. Man, that's so embarrassing, bro. I was blabbering on and on to myself, bro. That is tough. All right, number 6. A pediatrician uses the model above to estimate the height of a boy in inches in terms of the boy's age. So his height is a function of his age between the ages of 2 and 5. Based on the model, what is the estimated increase in inches of a boy's height each year? Okay, they're doing more talking than I am, bro. They're saying a whole lot of nothing. So all they're saying is this equation right here gives a boy's height as a function of his age. So basically, his height depends on how old he is. That's all they're saying. And so the question is, what is the estimated increase per year? So increase each year. Hopefully, we can see that as slope, rate of, or like the rate of increase or whatever, which is 3. It's saying he's increasing 3 inches for every time his age goes up by 1. 28.6 is like how tall he was when he was, in this case, at the age of 2. I was going to say when he was born, but it's between the ages of 2 and 5. So I'm going to go A. He is going up by 3 each year. Okay, number 7. What in the world? When you see a problem like this that looks extra, chances are it's not that bad. But let's see. All right, I want to make sure I can be heard. I'm going to unmute my video. But let's see. Okay, bet. All right. So the formula above gives a payment needed to pay off a loan. Which of the following gives P? Okay, again, they're saying a whole lot of nothing. They give you an equation. They're literally asking you which of the following is P. So just get P by itself. And then this is actually even more easy because if you think about it, all of this stuff right here is all being multiplied by P. So if I'm trying to get P by itself, I just got to divide both sides by that entire bracket. So it's just going to be M over all the stuff in green. That's literally it. Let me see if that's an answer choice before I start acting like it's nothing. Okay, so what was the stuff is, okay, it's a lot going on. R over 1200, 1 plus R over 12,000. Okay, so to get P by itself, it should be M over that. I guess they're probably keep change flipping. Since I don't see an M on top and the big thing on bottom, I'm betting that they're keep change flipping. So if I were to do that, I would keep the M and I would flip the fraction in the bracket. So this big old thing -1 should be on top, and then the top should be on bottom basically. And so that looks like B. Let me double check just to be sure. All right, yeah, it's looking like B. So that one was just a really extra complicated case of keep change flip. That's really all that was. All right, let's move on. Non-calculator, by the way. All right, number 8. I'll go to like, what time is it? 9. Let me go to like number like, I don't know, 15 or so, and then we'll do some calc. All right, so if A over B equals 2, what is the value of 4B over A? Okay, so when you see questions like this that they ask you for a value of something with 2 variables, usually a good strategy is to just manipulate whatever they give you. So I'm going to try to use, or like where it says A over B, I'm going to see if I can like fish out an A over B in this, and then I'm going to replace that A over B with 2. So they're talking about 4B over A. So I'm going to rewrite that. Now, I can kind of just see it, honestly. But I can see this as 4 times B over A. Hopefully, y'all can agree that those are equivalent. So I don't know what B over A is, but I do know that A over B is 2 over 1. Let me write that off to the side real quick. They're telling us that A over B is equal to 2, yes, but I'm going to write it as 2 over 1 because hopefully now you can see that B over A would be 1 over 2. So I'm going to write this as 4 times B over A, which I said was 1 over 2. So that's just 4 times 1/2, which is 2. And thank God that is an answer choice. I'm going with C. Okay, we're good now. Bet. Okay, good. Anthony, hey, if you're not doing anything, let me know if you're trying to join or not. I don't know. I'm going to do up until number 15, and then I'm going to do some fundamental theorem and calculus problems. My students have a test tomorrow. All right, so number 9. What is a solution to the system of equations? Okay, straight up systems of equations. They're trying to trick you, I can tell, because in this bottom equation, they're putting the y before the x. They're trying to trick you, bro. Don't fall for the traps. So what I'm going to do is I'm going to just rewrite it the normal, regular way with x and then y. So my first equation is untouched. My second equation, I'm going to write it as, I could say negative x, but just because I'm going to say negative 1x plus 2y equals negative 19. So I just reordered the left side on that bottom equation. Okay, so I'm picking a method. I could go substitution. I could easily isolate that x if I wanted to, but I'm just going to choose to go elimination. Now, if you really wanted to, you could just guess and check. It might take you a while, but I mean, if you get the right answer, you get the right answer. So I'm going to make one of my terms cancel out. Now, I'm going to do this strategically because I'm looking at my answer choices and I'm using them to my advantage. I'm looking at C and D. Both y coordinates for C and D are both -6. So I'm thinking that it might be between C and D. I'm just guessing. I don't know. But what I'm trying to say is I'm just going to solve for x in my system of equations. Because once I solve for x, I won't need to solve for y because all the x's are different. But on C and D, the y's are the same. So I'm just going to solve for x. And so I'm going to do that by what? Canceling out my y's. So for these to cancel out, this 2 right here, my 2 from my 2y, these would cancel out if that 2 was a negative 4. Because 4y and negative 4y would cancel out. So I need to be like, all right, if I want this to become a negative 4, then I can't just change it. But I got to multiply everything by what? Negative 2. Because negative 2, once I distribute that, negative 2 times 2 will give me negative 4. But, you know, I got to do the same thing on the other side too. I got to times by negative 2. I don't like the way that looks. I'm just going to do it like this. Not subtracting 2. All right, so let me distribute. This will be a negative times a negative is a positive minus 4y. We expected that. I don't know. What's 19 doubled? That's like 38. I think. I hope. That sounds right. Okay. So that is my new bottom equation. That is my new bottom equation. Now, I should have rewritten my top equation so I can keep it like consistent. So I'm going to just keep my top equation on top. And I'm not changing anything with my top equation. It's just 3x plus 4y equals negative 23. My bottom equation is the same as it was originally, but I just times everything by negative 2. So we're still good. But the good thing is now when I add these together, my y's cancel. 4y minus 4y is just 0. So I got, what, 5x equals, what's 38 minus 23? Is that 15? That would make sense because x would be 3. But I did that quickly. Hold on, let me make sure. 38 minus 20 would be 18, minus 3 would be 15. All right, yeah. So because x is 3, I know it's b. Okay. Number 10. For the function g defined above, a is a constant and g of 4 equals 8. What is the value of g of 4? G of negative 4. Okay, bet. So they're telling us that when x is 4, y is 8. Okay. So I'm going to use that because I can't find g of negative 4 until I know what a is. I got to figure out a first. And here's how I'm going to do that. G of x, that's like my y. They're telling us that when y is 8, x is 4. So I'm going to go a times, like I said, x is 4. That is being squared plus 24. I can use that to find a, and then once I know a is going to be a regardless of what x is. So, and how do I know that? I'm glad you asked. It's because they tell us that a is a constant. So a does not change. All right, so let's solve for a. So I got a equals 4 squared is what, 16? 16a plus 24. This is non-calculator too. So I got a minus 24 from both sides. What the heck is that? 24, 23, 22, 21, 20, 19, 18, 17, negative 16. Okay. That would make a negative 1. Okay. Now that I know that, I can find g of negative 4. So I'm going to do that right here. G of negative 4 is just this thing, but whenever x is negative 4. And again, we know that a is negative 1. So I'm going to say negative 1 times. Now, if I'm taking this during the test, I'm going to just do this part in my head. Negative 4 squared is just 16 plus 24. So negative 1 times 16 is negative 16 plus 24. What is that? 8. And that is an answer choice. I think it's 8. I know it's not negative and I know it's not 0. So I guess 8 is justifiable. All right. If somebody's watching this back in the future, let me know like how I did or whatever. Okay. I said I was going to go to number 15, but I'm really itching to do some calc. So I might just finish this page. I'm not going to lie. Yeah, we're doing 11 and 12. All right. In the equations above, B and C represent the price per pound in dollars of beef and chicken X weeks after July 1st. What was the price per pound of beef? Okay. So the price per pound of beef, it tells us, is represented by B. B represents the price per pound of beef. Okay, so they want to know B when it was equal to C. Okay, so B and C are, we're trying to find when B and C are equal to each other. What is B when they're equal to each other? So if B is all of this and C is all of this and they're equal to each other, I'm going to just set those equal to each other. And then solve for X. Let me tell you my strategy first. I'm going to set these two equal to each other. That's going to allow me to solve for X. And then whatever X is, I can plug it in here. And then I can get my B. That's my plan. Okay, so 2.35 plus 0.25x equals B equals C is what I'm writing right now. 1.75 plus 0.40x. Okay, I got to solve for x. Now, I'm noticing that there's an x on both sides, so I'm going to subtract the smaller. One of my freshmen taught me, their middle school teacher said, bring the baby to the mama. I was like, okay, I guess. It makes sense. I never heard of that before, but I'll take it. We're taking the smaller number and bringing it over with the bigger number, the baby to the mama. All right, so that's going to make my x cancel out on the left. So that'll leave me with what? 2.35 equals 1.75 plus, oh Lord. I'm going to minus 20 and then I'm going to minus 5. So 15.15 x. Seems right. Now I'm going to minus 1.75 from both sides. Minus 1.75. Minus 1.75. Bro, I don't know what that is. This is the stuff that's going to make me panic on the test, bro. What is 2.35 minus 1.75? And then I got to divide that by 0.15. Is that what they want us to do on this one? I guess. Yeah, I guess. Okay. Bro, $2.35 minus $1.75. All right, let's think about this. If I got $2.35 and I take away $1, then I got $1.35. And then I gotta take away 75 cents from 135. Bro, I haven't subtracted decimals in so long. I want to see if I can still remember how to do this. So if I take 2.35 and minus 1, that'll give me 1.35. And from that, I have to subtract 0.75. So I started with 2.35, I subtracted $1, and then I'm subtracting 75 cents. How do we do this? Is it like what I remember it being when I was a kid? What do we do? Borrow a 1, change that to a 0. 13 minus 7, 12, 11, 10, 9, 8, 7, 6. Is it 60? 0.60? Okay, that actually makes sense because 15 goes into 60. So I think we're good. 0.15 times what gives me 0.60? I'm going to just count by 15s. 15, 30, 45, 64. So x equals 4. But that's not what we're trying to find. Remember, we're trying to find b whenever x is 4. So b of 4 is how you could think of that. Equals 2.35 plus 0.25 times 4. A quarter, 4 of them, that's $1. So plus 1. That's 3.35. And, ooh, that is an answer choice. Let's go. All right. That one wasn't easy. I think the hardest part was the decimals. Yeah. Okay, bet. All right. Last one, and then it's calc time. Okay, so a line in the XY plane passes through the origin and it has a slope of 1/7. Which of the following points lies on the line? Okay, I guess I could sketch. It tells us a line that passes through the origin. So I know that point is on the line. And if the slope is 1/7, then I know it goes what? Up, rise over run, up 1/7. So I'm just going to estimate it to be right here. This point is up 1/7. Ooh, wait, I wrote that wrong. 7,1. I almost got that problem wrong. Okay. Which of the following points lies on the line? All right. Well, 0,7 doesn't, of course, because 0,7 is way up here somewhere. I guess I could sketch my line. Something like that. So we can clearly see that 0,7 is not on the line. 1,7 is somewhere up here, which that can't be on there. 7,7. No, because 7,1 is on the line. So those both can't exist. 14,2 makes sense because if I go up 1/7, up 1/7 again, then I would be at 14,2. So I'm going to go D. Okay, I'm ready to do some calc. If anybody watches this back and pulls up this test from the Discord and they want, problems work, just let me know. All right. Hey, Anthony just posted. Let's watch it. This will be our transition to calculus. Perfect. Okay, what? Find the limit. Wait, hold on. Let me guess. You plugged in pi? Oh. Cosine over sine. I like these jokes, bro, because they actually cover a lot of misconceptions. And the sound too.
Come on, man. That's too easy.
All right, bet. So, now for calc, what do I want to do? I want to do, let's do some, I want to do the ones from this that I haven't done yet, because I haven't done every problem on here. Now, if you're wondering where this one is, I think I posted it in the Discord. Let me see. If I go to Calc AB, it's there. FTC problems. If I pull it up, oh, I don't want it to download. But yeah, that's exactly what I'm working on. Okay. So let's do it. Fundamental theorem of calculus. The integral differentiated is just the function itself. If I have an integral, I have a function that represents my integral. I can evaluate it at the upper bound minus the lower bound, and that'll give me the exact area under a curve. So so for my test, for those who are watching, it's basically all non-calculator. So I want to see if actually I think I might have done all of these actually, now that I think about it. Yeah, I did do all of these. All right, well, let's do something that I haven't done then. Actually, I don't know if I can stream that. I know what I'll do. I'm going to, I think I have another problem set with FTC problems in it. Hold on, let me see. Practice problems. Yeah, this was from this one I got practice tests or actual tests from the 70s. The 60s, 1969 is crazy. Okay. Yeah, if y'all can read this, can y'all read this? Yeah. I'm going to try to do these. Let me post in my group chat real quick. Okay. I wish it didn't have the answers already there. But dang it, bro. I don't want something that has all the answers. I'm just gonna redo these because I know not everyone did these, and these are some good problems. These are some really good problems. Um, but again, if there's anybody, I don't even. Is there even anybody watching? There's one person watching, and I think so. I got my stream pulled up on my other monitor. I think I am the one viewer that they're talking about. That's tough. That is tough. Anyways, um, okay. Oh, you know what? Let me post on my TikTok story real quick. Let me just see if I can make something happen. All right, how do I post on my story? Can I do a boomerang? Nope. Bro, that is not. I don't know how to post on my story. So many people are going live on TikTok. Is it? Ah, I found it. I found. No, not a TikTok now. Bro, where's the stories? There's gotta be a way. Is that not a thing anymore? Now? I don't know, bro. Wait, can you. Hold on. One moment again, please. Is that a thing? Tap plus at the bottom of the screen. Use a camera, start. Okay. Oh, I just gotta make the post and then post it to my story. Okay, bet. Um, okay, I guess that'll do. Do I get to add text and stuff to it? Okay, bet. Oh, I can't put links in here, can I? All right, I'm gonna just say link in bio, and I'm gonna make the lady talk. Post the story. All right, I did it. I think story. Okay, story was uploaded. Okay, bet, bet. I don't see it, but I'm gonna just trust it. Okay. Um. Now, fundamental theorem of calculus. I'm gonna write the theorems first. I'm just gonna write them so that we can be reminded of what they say. So there's two of them. The first part says, I'm just going to call this FTC part 1. And I've actually seen part 1 called part 2 and part 2 called part 1. I don't know. But it basically says if you have an integral from a to b of some function, you can evaluate the integral of that function at its upper bound and subtract it from that integral's evaluated at the lower bound. I guess I should add when capital F is the antiderivative of little f. I could say integral. I still don't know if there's a difference between saying antiderivative and integral. But that is what the theorem says. Plain and simple. Now, part 2 says, this one is like kind of neat and convenient. it says that if you have a derivative of an integral from some number, it doesn't matter what number it is. Actually, yeah, so because it doesn't matter what number it is, I'm going to put a to x of any function. The derivative and the integral cancel each other out. That's basically what it says. So this is just equal to f of x. All right, it's equal to the function evaluated at the upper bound minus evaluated at the lower bound. But remember that this is like capital F of x minus capital F of a. Capital F of a is a constant because a is a constant. And so since you're taking the derivative of that, the derivative of a constant is 0. So if you want to be technical, then you can say minus 0 because you're using part 1 technically. But okay, so that's what that says. And in fact, number 1 is literally FTC part 2 exactly, down to a T. No pun intended. But the derivative of an integral is just the function itself evaluated at the upper bound. Well, it's really evaluated at both bounds, but again, the derivative of something evaluated at a constant is just 0. So it's A. It's A. Okay. Number two. Okay. This one, it tells us g of x is some integral, and then it asks us for g prime of x. So this one is basically asking you to find the derivative of an integral, which is just the function itself, evaluated at the upper bound minus the lower bound. So this is going to be basically cosine of, now if I take that pi x and replace it for t, that t is being squared. So I'm squaring pi x, which I can express like so. However, because I'm taking the derivative of a function inside of a function. That's essentially what's going on, because cosine is a function. And then what I'm plugging inside of the argument of cosine, which is pi x, that is also a function. And so because we're taking the derivative of a function within a function, we have to use the chain rule, which says we multiply this thing by the derivative of the inside. That is what chain rule says. So if the inside is pi x, then the derivative of that is just pi, giving us e. Pi times cosine of pi squared x squared. All right, now I'm going to be honest. My students have seen these problems. I've seen these problems. I really want to find like a fresh problem set. A fresh problem set where I don't know the answers, and yeah, because I've done these already before. Oh, wait. I know. Because I found a test. Where did I save it? I found a test earlier today, and it is categorized by topic, and they categorized all the FTC problems. This is exactly what it was. Okay, so unit 6. So all of these are all FTC problems. So let's do these, because I haven't done all of these before. So this is going to be a lot fresher. And if I do recall correctly, I think they do have the answers. This is like a whole practice test too. I should probably put this in the Discord. I think I will. Do they have answers? Yes, they do. Okay, bet. All right, so before I proceed, I'm going to put this in the Discord. And then we can do all the FTC ones, which starts at number 3. So let me take this. How do I share this? Right click. Share. Yeah. Anyone with the link, copy link, boom, Discord. AP Calc. Paste. Boom. Okay, bet. All right, now. What I also, dang it, I probably should have did this before the stream. I'm sorry. I'm gonna download it so that I can write on it. So let me do that real quick. Where are we going? Dropbox. Calc AB. This is a practice test. Paste. Okay, bet. Now, here, I'm gonna go add a page, insert file. Patrick Cox. All right, bet. Now this file is pretty big, so it's gonna take a second. But oh, I lied. Never mind. It's already here. All right. I remember they were starting on number. Which one was it? FTC Unit 6, number 3. Okay. As I look at number 3, already I see an integral and a derivative. So that is FTC. So let's go ahead and do that one. Okay, so the graph of a piecewise linear function f of x is above. So this is the graph of f, and they want to evaluate this integral. All right, so let's see. We have an integral of f prime of x dx. Now, remember that integrals and derivatives cancel each other out. So the integral of this derivative is just f of x. But because we have bounds, we can use FTC part 1. We can use FTC part 1 here because we have a definite integral. And because we know the integral of f prime is just f, we can say this. We can say this right here. So that is what they want us to evaluate. The thing that they want us to evaluate is the same thing as saying little f of 8 minus little f of 3. Now, fortunately, we have a graph of f. So we can use that to find f of 8 and f of 3. So according to the graph, f of 8 is 0 minus f of 3 is 2. So 0 minus 2 is an answer choice. Okay, that was not that bad. Like, here's my thing about FTC problems, bro. Like, they're not like, if I say they're not hard, that doesn't imply that they're easy. Because they're not easy, but they're not like hard. I don't know. It's weird. It's hard to explain because no two problems are the same. And so that kind of makes it hard to say. Now, number 4 is not an FTC problem because it's just a straight up integral. I guess we could do it though. It doesn't hurt. Okay, so we can say now it's a fraction, yes, but I'm gonna like reverse combine fractions. Here's what I mean. I'm gonna take the integral from 1 to 5. Instead of saying x minus 1 over x, I'm gonna basically split it up into 2 fractions. I'm gonna say x over x minus 1 over x. Because when I integrate stuff, I'm always looking to do it term by term. That makes it a lot easier. So I'm literally just integrating 1 minus 1 over x. That x over x, of course, is 1. So I'm just trying to think backwards. Whenever I integrate, I'm just thinking backwards. Give me something to where when I derive it, I get 1. And where's 1 coming from? Again, that's just x over x. I guess I'll be thorough and write it so I don't confuse my viewers, or my potential viewers, I should say. So this is the same thing as saying 1 minus 1 over x, the integral of that with respect to x. All right, so now I'm just thinking backwards. I know if I take the derivative of x, I get 1. Minus, now again, thinking backwards, I know if I take the derivative of the natural log of x, then I'll get 1 over x. So this x minus ln of x, you can think of that as like my capital F of x. and then we're going to evaluate it at 5 and then subtract it from evaluated at 1. So that's what I'm about to do now. So again, this x minus ln of x, this stuff right here, you can think of that as like your capital F of x if you're thinking fundamental theorem of calculus. So we're going to do capital F of B minus capital F of A. And that is 5 minus ln 5. 5 minus ln 5 minus parentheses because I'm subtracting a whole quantity. 1 minus ln of 1. But I feel like ln of 1 I know because that's like e to the what equals 1. E to the 0 equals 1. So this is really 5 minus ln 5 minus, now this parentheses 1 minus 0 is just 1. So I'm just subtracting 1. I see a 5 minus 1, which is 4, minus ln 5. I get B. 4 minus ln 5. Okay, sweet. Okay. I'm just going to say it. Some of the, so for my students watching, I pulled the test questions from here. Hopefully that prompts you to join the live. Oh wait, should I? Nah, I'm not gonna tell them. Maybe I'll tell them. Yeah, I'll tell them after the fact. Yeah. Hopefully that's not evil. All right, so I know number 5 is not a problem. Okay, so we have 3, 4, 11, 19, 20. 11. Ooh, okay. Number 11. If f prime of x equals, 3x squared, and f of 2 equals 3, then f of 1 equals what? Now, I'm thinking f of 2 and f of 1, that's giving like f of b minus f of a. You know what I'm saying? And so because of that, I can tell, like, I'm going to let a be my smaller x value and b be my bigger x value. So, all right, so let's try to come up with an equation based on fundamental theorem of calculus. So let's kind of use the definition here. That's kind of like my default method or default like strategy whenever it's not like immediately clear what to do, just write out the facts. So what do we know for facts? If I let a and b be 1 and 2, then I can say that the integral from 1 to 2 of, now the functions that are evaluated at a and b are lowercase f. And so I'm really just thinking backwards right now. I'm integrating this. Because what is the integral of f prime? That's just f itself. The integral of f prime is just f itself. That's what FTC part 2 says. So because of that reason, I can say that this integral right here is equal to this. F of 2 minus f of 1. Okay. That is quite literally FTC 1 and 2 in one problem. Yeah. So they tell us f of 2 equals 3. So this equation, they're kind of giving us some stuff. So they're telling us that f of 2 is 3 minus this f of 1 is what they want us to find. Okay, do I know what the left side is? The integral of f of x, or f prime of x. Now, they tell us what f prime of x is. So the integral of 3x squared is something that when I derive it, I get 3x squared back. And again, I'm just thinking backwards. This whole semester is a lot of thinking backwards. What can I take the derivative of that'll give me 3x squared? And that is x cubed. That is x cubed. So x cubed. If I take the derivative of x cubed, I do get 3x squared. So this integral is correct. And because it's a definite integral, I'm going to evaluate it at 2 and 1. That is kind of what's going on the left side. So here's my strategy. I'm going to take this x cubed and evaluate it at 2 minus x cubed evaluated at 1. And then let's see if I can solve for f of 1. So 2 cubed is 8 minus 1 cubed is 1 equals 3 minus f of 1. 8 minus 1 is 7. 7 equals 3 minus what? Okay. Now, I'm thinking -4 just from thinking backwards, but if I want to do it algebraically, that's fine. I'm just going to try to get f of 1 by itself by subtracting 3 from both sides. That'll give me 4 equals negative f of 1. So hopefully by now you can see that positive f of 1 would just be -4. If you can't see it, just divide or multiply both sides by -1. So I'm going to go with B. Okay, that one, okay. Is that question considered hard? I would say yes if you're in my class, because I will admit that we have not done one like that before. But at the same time, we're just applying FTC. We're just using definition of FTC straight up. And a little bit of backwards thinking, which that's essentially what integration is, kind of. Okay. Let's keep going. Hold on. I'm going to pull up the FTC problems on my phone so I don't have to keep scrolling. Where is that test at? Give me 5 seconds. Hold up. Okay. Calculus. Where is, oh, here it is. All right, found it. So what was that, number 11? All right, they're saying number 19. Number 19. Okay. I love doing problems that I've never done before. This is fun. Okay, so let g be the function given by, wait, what? Let g be the function given by f of x equals the integral of that. What is the coordinate? I'm assuming they mean f. What is the x coordinate of the point of inflection of the graph of f? Okay, I'm gonna assume that they meant f right here because there's no other mention of g. But anyways, this is our function of interest. I hate how this does that. Dang it. What number was I on? Here we go. All right, so the x coordinate of the point of inflection. Hold on. God dang it, bro. I meant to make my highlighter a little bit thicker. Hold on. All right. So point of inflection is what I was trying to highlight. Remember, points of inflection can be found when taking the second derivative. So I gotta look at f double prime. I gotta look at f double prime. So f double prime of x. Well, there's f of x. So f prime of x would just be the function itself. So f double prime would be the derivative of the function itself, which would just be 3 minus 12t or 12x. Okay, so we're just finding points of inflection from that. Points of inflection happen when the second derivative changes sign. So either from negative to positive or positive to negative. If either of those happen, then the second derivative at some point has to equal 0. So we're going to figure out at what point that is. I'm going to add 12x to both sides. Or I could factor out a 3. It really doesn't matter. But this is me adding 12x to both sides. And then if I divide by 12, I get 3 over 12, which is 1 over 4 equals x. Okay, so that is the only possible inflection point. I want to go B. All right. Let's do a couple more. 3, 4, 11, 19, 20. Ooh. Okay. It's like backwards chain rule. You could use U sub, but I'm not going to do that. Now, if I'm like, okay, if I haven't learned a lot of integration techniques like U sub and like trig integrals, honestly, if I'm taking the test, I'm just going to differentiate each one of these answer choices and see which one gives me sine of 3x. I want to say it's D. I want to, just from looking at it, I want to say D. If I take the derivative of D, what do I get? If I take the derivative of D, that is negative 1/3 times the derivative of cosine is what? Negative sine of 3x. But because 3x is a function, I got to multiply by chain rule. I mean, use chain rule, so multiply by 3x. I'm talking too fast. Multiply by the derivative of 3x, which is 3. Now, if I simplify this, the two negatives cancel out. The 1/3 and the 3 cancel out. So I do get sine of 3x. Plus 0, technically, because the derivative of c is just 0. But, yeah, we got D by inspection. Okay. 22. Number 22. Oh, Lord. Okay, this one, okay, so I don't think this one is a FTC problem. It looks like just knowing the properties of definite integrals, just from looking at it. So because this is an FTC stream, I'm going to skip this one for right now. 29. That's not even FTC. That's just straight up integral. It's screaming U sub, bro. Because if I let U be x squared plus 3x to the 4th, no, just that, then du would just be 2x plus 3, which I see that. So I can literally rewrite this integral as the integral of u to the 4th du. If I replace u with what I defined it to be, and if I replace du with what I defined it to be, then I have exactly my integral. So that's okay. That's easy. Now I can just use reverse power rule, which is u to the 5th over 5 plus c, and then just switch my u's back. U we said was what? X squared plus 3x to the 5th over 5, which looks like a. Yeah, oh, I forgot the plus c. Okay, even though this wasn't an FTC one, we still did that one anyway. That's fine. If you're watching this and you take my class, this is like 6.9, I want to say. Okay, so they're saying that number 78, it goes 20, 22, 29, 78. I did not know this document was this big. Oh, okay. All right. Let f be a continuous function such that the integral of f of x from 2 to 5 equals -4, And then the integral from 8 to 5 equals 3. This is straight up properties of indefinite integrals. Yep, that's exactly what that is. Okay, number 79. All right, this one is I'm thinking FTC because I'm saying differentiability and integration in the same problem. Okay, so it says let f be, what time is it? 9:46. I'm about to go to bed soon. Let f be a twice differentiable function defined by the differentiable function g, such that f of x is the integral of g of x. Okay. It is known that g of x is always concave up, decreasing, and positive for all real numbers. Which of the following could be false about f? Golly. Okay. All right, so let's see. I hope I can get this one right. Okay, so if g of x is always concave up, then I know that the second derivative of g is positive. That's what that means. G of x decreasing means that the first derivative is negative. I'm writing this out, and I should probably sketch it out too. And it's positive. So g of x itself is positive for all real numbers. Okay, so which of the following could be false about... Okay, this one doesn't seem too bad. It's just incorporating integrals and derivatives canceling each other out while basically involving all the like first derivative stuff, or not first derivative, first semester stuff, increasing, decreasing, concavity, etc. Okay, so this one actually might not be that bad because there's a relationship between g and f. G is, let me make sure I say this right. If I take the derivatives of both sides, let's write that over here. If I take the derivatives of both sides of this equation, then I have f prime of x equals g of x. Because when I differentiate an integral, they cancel each other out. So if g of x is positive, then that means that f prime of x must also be positive because g and f prime are the same thing. Okay, now if g prime is positive, that means that f double prime of x is, negative. Okay. Now g double prime, that would be f triple prime. What does f triple prime tell us? Okay, let's see. Which one could be false? So I'm going to scratch out all the ones that are definitely true. A says f of x is concave down. Concave down means that f double prime is negative, which is true. So this one could not be false. That is guaranteed to be true. B says f of x is increasing. Now, see, that's what I don't know. It might be B because we don't really know anything about f of x, do we? We know it's twice differentiable. And we know, yeah. Okay, what about C? F of x is negative for all x. Actually, wait. I take that back. F increasing means that f prime is positive. I'm tripping. And f prime we know is positive. So B cannot be false. C is really what we don't know because we don't really know anything about f. But let me read D though. F of x equals 0 for x, for some x in the real numbers. This one is kind of tricky. If G is always concave up, decreasing and positive, which of the following could be false? F of x equals 0. Oh. I think I think it's C. I think it's C. I think it's C because let me explain why. I think D has to be true. For f of x to equal 0, remember, what is f of x? F of x is this whole integral from -2 to x. So when does that integral equal 0? When x is -2. Because what's the integral from -2 to -2? It's just 0. And it says for some x in the real numbers. -2 is an x value in the real numbers. So this is true. So I'm going C. That one was hard. That one was hard. I'm not gonna lie. I low key started panicking a little bit. I'm not gonna sit here and lie to y'all. All right. Hopefully it's right. I should probably check before I, Okay, so this says 78, 79, 86. This is the last MCQ, and I guess this is the last one I'll do. 86. 86, 86, 86. Okay. This one, just from looking at it on site, I already see that this one shouldn't be that bad. I'm hoping that it's not that bad. And I can already see where they're going with it because I see the G of 3 and the G of 6. I'm thinking f of b minus f of a. So let me write out a fact. Let's see. Ooh, this has to be calculator. Looking at those answer choices. So I'm going to write a fact. And because we're talking about G of 3 and G of 6, I can say that the integral from, again, 3 is going to be my A and 6 is going to be my B. So I'm going to say the integral from 3 to 6 of f prime of x. Okay. The integral of the derivative is just a function itself. So this is going to be, according to FTC, both 1 and 2, this is going to be equal to f of 6 minus f of 3. Okay. And again, we know f. Oh, wait. There's G's. Hold on. With the first derivative. Why are they saying G? Should this be F? Are there typos? I feel like this should be a G. I mean, it should be F. That's what I'm feeling like. So I'm going to assume that they made a typo only because there's no other mention of G. Yeah. I could see if they said let G be a function that has that derivative. That would make sense. But anyways. Ooh, wait. We would have to integrate that, I feel like. Do we know how? Oh, I did this last time. This is calculator active. And how do I know? Usually when you have funky decimal answer choices like that, like you're not going to get that without a calculator. And I was kind of starting to panic a little bit because I was like, I don't know how to integrate that. But remember, we can use our calculator. And I'm about to do that. I'll do the on-screen calculator so y'all can see what it looks like. But we're going to use the calculator to, actually, I'm going to rewrite this using the actual function instead of just f prime of t. But we're going to use the calculator to calculate the integral from 3 to 6 of all of that. Plus cosine of x plus 2 dx. And that is going to be equal to f of 6 minus f of 3, which they told us is 4. All right, calculator time. So we're going to go boom. Actually, I'm going to pull it up over here and then drag it over. Okay. Okay, sweet. So we have to calculate this stuff right here. Hold on. All right, so I'm going to go math and then scroll down to integral, function integral. I think that's what it is. Yeah. And we just literally type exactly what we have. The integral from 3 to 6 of, now let's just make sure we type it in right. The square root of sine of x. Am I in radian mode? Yes. Sine, wait. The square root of sine of x plus cosine of x plus 2 dx. 3.198255476. Okay, so to get f of x, not f of x, I'll be talking too fast. To get f of 6 by itself, algebraically, I can just add 4 to both sides. And the calculator told us that the left side was 3.198. 3.198 equals f of 6 minus 4. Add 4 to both sides. Oh, is that another typo? Goodness gracious, who wrote this? Or wait. Let me make sure I didn't make a typo before I start going off. 3.198. Dang. This one, so I got 7.198. I'm hoping it's D. I think. All right. Huh? What is it? A towel? What do you mean, what is it? I guess. I don't know. Oh. On the towel? Oh. Oh. So, I don't understand your question. Oh. Yes. Well, I just had somewhere to put it because I use that to wipe up Cake's pee. What? I didn't know where else to put it. Yeah, I guess, but I had clothes in there at the time. Oh, well, oh, bet. Dang it. Okay. I think that was the last MCQ. I'm gonna check my answers and then I'm about to get off. Yeah, that was the last one. 86. Yeah. Okay, so here's what I'll do. I'm going to pull up the answer keys side by side. And we're going to see how we did. Hopefully, bro. If I miss one. Okay, let me find the answers. There's a lot of calculus problems, bro. Here we go. Okay, so the problems that we did were all right, so they were number 3 and 4. Bro, hopefully we got these right. Okay, number 3. We got B for number 3. Yes, number 3 is B. 4 is B. Yes. Okay, bet. We're good. 11. Bro, hopefully I go undefeated. 11 is B. 11 is B. Bet. Number 19. Number 19, I got B. They said number 19 was B. Let's go. Okay, bet. Number 20. Bro, I hope I don't miss one. I got D. They said 20 was D. Let's go. Number 22. Oh, that wasn't an FTC one. That's right. We skipped it. Number 29. I got A. Number 29, they got A. Let's go. That one was pretty easy, though. Number 78. That was not an FTC one. We skipped it. Number 79, I got C. They got C. Let's go. Whew. That was a hard one I was worried about. 86. 86, I got D. 86, they got D. Let's go. Let's go. All right. We're undefeated. So I'm not gonna do them now because, like I said, I'm about to get off. But I at least want to look at the FRQ questions. I just want to see what they're talking about. And FRQ number 3 is what they said. Are these the FRQs? These are the FRQs. Number 3. Okay. Anytime I see a graph with a semicircle on it, you know it's FTC. You're probably gonna have to find the area underneath something. Yep. This is a very common one. Find f prime or f of -4. I'm guessing that B is going to be find f prime of -4. Oh, never mind. I see that one a lot. That's why I say that. Increasing and concave up, you know, that's first and second derivative. Horizontal tangent, that's where f prime is 0. Minimums and maximums, you got to find critical points. FTC part 2, right there. That's a good one. I like that one. FRQ 5. Wait, where's number 5? Oh, that's number 5. Okay, they're talking about twice differentiability and there's an integral sign. I'm noticing that that top bound is a function. Ooh, they got a Riemann sum in here. Find G prime and evaluate G prime of 3. Estimate f prime of 3. I noticed they said estimate, so I'm just going to use rise over run. Y2 minus y1, etc. D, it just looks like, what was it? Mean intermediate value theorem? One of those value theorems. Probably mean. Yep. Okay. What else is FRQ 6C? Yep. Like once you do these enough, you should start to like get a feel of what they're gonna ask. I see an integral of G prime. So you know what I'm saying? That's just FTC. Okay. I'm about to get off now. Hopefully I helped. Let me know and I'll be back on again.